Okay, everybody, I'm down Wenatchee, so I'll be back, but I'm probably going to miss this period. Review day 1, 10, 19. If you guys need the substitute to pause the video so you can get caught up, just please ask. So here we go. So given triangle PIG, find the value of each trig ratio. Now the ratio means fraction, okay? So I need fractional answers. So let's start with angle P. I need the sine of angle P. I need the cosine of angle P. And I need the tangent of angle P, because those are my acute angles. So from angle P, opposite, adjacent, hypotenuse. Okay? So sine, opposite, over hypotenuse, 8 over 17. That's all I need. Cosine, adjacent over hypotenuse, 15 over 17. Tangent of P, opposite over adjacent, 8 over 15. Okay, not bad. We're going to do the same thing with angle G. We're going to find the sine of angle G, the cosine of angle G, and the tangent of angle G. Now the only thing that happens when you go to angle G is that the 15 now is the opposite side and the 8 is the adjacent. So we switch around the words, the names of the sides, and we'll now do sine, opposite over hypotenuse, 15 over 17. Cosine of G, adjacent over hypotenuse, 8 over 17. Tangent of G, opposite over adjacent, 15 over 8. That's it. So all you have to do tomorrow is just rewrite the fractions. Don't solve it, I just want the fractions. Okay, now 2 is different. In 2, we're actually going to solve it. So first thing I'm going to do is find the easy stuff, angle A. So first one, let's find angle A. And that's just going to be 90 degrees minus 50 degrees, which is 40 degrees. Okay? Angle A is 40. Second thing I'll do, once I know the 40 here, is I'm going to find probably either little a or little t. I'm going to find little a, doesn't matter, so I'm going to find a, and to do a, I'm going to take and use my cosine, because I've got my hypotenuse, and I want to find my adjacent. Alright, so I'm going to set up cosine of 50, and cosine is equal to the adjacent, which is little a, side a, over the hypotenuse, which is 12. Multiply up to 12, and I'll have 12 cosine of 50 is equal to a, and I'll just use my calculator. 12 cosine 50, and an answer of about 7.7. So little a, or side a, is 7.7. Okay, then if I want to find t, if this is 7.7, I'm just going to use Pythagoras Theorem. I'll set up my t squared plus my 7.7 squared equals my 12 squared. If I'm going to solve for t squared, I'll minus 7.7 squared, so t squared is equal to 12 squared minus 7.7 squared, and I'll just use my calculator. 12 squared minus 7.7 squared, I get t squared equals 84.71, square root, and I get an answer of 9.2. Okay, so far so good, hopefully for you guys. Okay, just like this tomorrow. Okay, alright, moving on to problem number 3. Okay, in problem number 3, first of all, I could either find angle B or angle N. It doesn't matter. I'm going to go for angle N. Okay, if I want angle n, then I have to use my inverse button. If I want an angle, I have to use my inverse button. From n, opposite, adjacent, I'm going to do tangent. So I'm going to do tangent inverse, because I want to find the angle of the opposite over the adjacent, and that will give me angle n. So I'm just going to use my calculator and go tangent inverse, second inverse of 3 divided by 10, and I get an answer of 16.7 degrees. Okay, 16.7 degrees. Okay, once I get angle n, angle b is very easy because they add up to 90. So angle b is equal to 90 degrees minus my 16.7 degrees, and I'll just use my calculator. 90 minus my 16.7, and I get an answer of 73.3. Okay, there's angle B. And then finally, we want to find this hypotenuse, this third side. Let's call it little e. I want to find little e. I'm going to use Pythagoras Theorem. 3 squared plus 10 squared equals little e squared, so I'll do that on the side. I will do a 3 squared plus a 10 squared equals a e squared. 9 plus 100 makes 109 equals e squared. Square root, square root, square root of 100 is about 10 point something, I'm sure of that. Square root of 109, 10.44. Or 10.4. Okay? Not too bad. Hopefully you can do this tomorrow. Okay? Alright. Number 4. It turns out this is a 45, 45, 90 triangle. Well, that makes it easy for me because it's half square. 8, 8. So this is just going to be 8 square root of 2. So this is the triangle, the special triangle that's up on the wall right above all of your figures. Okay? Number 5 is a special right triangle also. Now if I turn it this way, it's easier to see. Okay, 30, 60, 90 triangle. The 20 is twice as big as this side. 20 is twice as big as this side, so this side's got to be 10. And this leg is going to be whatever this is times the square root of 3. 10 square roots of 3. And again, triangle is right above me, up above on the board in blue. Okay, it's a special right triangle. Okay. Number 6, I turn it back around. Again, it's a 30, 60, 90 triangle, but the dilemma we have is right here on this side. If you look above, is some x square roots of 3. Okay, so if I need to find x, I'm just going to solve for x. I'm going to go, okay, what is 18 is equal to x square roots of 3. If I want to solve for x, to get x, I'm going to divide by the square root of 3, divide by the square root of 3. 18 divided by the square root of 3 is the square root of 6. So this side, x, is just going to be the square root of 6. Okay, now, this side here, if you are asked for this tomorrow, is twice that. 2 square roots of 6. So far, so good. Let me grab some graph paper and let you catch up. Alright, I'm back. So, got some graph paper. And first I want to graph triangle RST. So I'm just going to go ahead and do that first. My y-axis, my x-axis. Let's go ahead and put down R, which is at 4, 3, 1, 2, 3, 4, 1, 2, 3, there's R. S is at negative 2, 1, 2, 1, 2, 3, that's S. And then T is at negative 2, negative 5, 1, 2, 1, 2, 3, 4, 5, and there's T. All right, let me draw my triangle. And let's take a look at what I have. All right. Now, if I want to find angle R, well, let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. To find angle R, I'm going to use my inverse button because I need to find an angle. So let's see. Opposite from angle R, adjacent. Opposite, adjacent. So I'm going to do tangent, but tangent inverse because I want to find the angle. Tangent inverse of my opposite over my adjacent will give me angle R. All right. So I'm going to use my calculator. Tangent inverse, 8 divided by 6, and I get an answer of about 53.1 degrees. Okay, that wasn't so bad. RT is this third side. Well, let's just use Pythagoras Theorem. To find RT, let's call it, we'll go 6 squared plus 8 squared equals, we'll call it C squared if you want to. It's really a little S squared. I get 36 plus 64 equals 100 square root, and I get 10. There it is. Okay. So far, so good. Let's turn the page, and let's do the back. Okay, a lot of story problems, but the nice thing about story problems is really we only have to find one thing. We need to draw a right triangle. So we need a right triangle for all of these. Okay, so number 8. An 18-foot ladder leans against a 12-foot wall. So let's draw a picture. Okay, here's my 12-foot wall. Here's my 18-foot ladder. What's the angle formed by the ladder and the ground? Okay. So we're going to have to use the inverse button because we're looking for the angle. Opposite, hypotenuse. Opposite, hypotenuse. I'm going to use the sine, but the inverse. Sine inverse, because I'm looking for the angle, of the opposite over the hypotenuse will equal theta. Okay, I'll just use my calculator. Okay, so I'm just going to go second sine inverse of 12 divided by 18, and I get an answer of about 41.8 degrees. Theta is about 41.8 degrees. Okay, not too bad. Number 9. Okay, the shadow of a tree on the ground is 18 feet long. The angle of elevation of the top of the tree is 54. What's the height of the tree? Let's draw a picture, okay? So here's my tree, and I have a shadow that's 18 feet long. My angle of elevation is 54 degrees. All right? And I want to find the height of the tree. All right, let's look at this. Opposite, adjacent. Opposite, adjacent is tangent. I don't need to find the angle. I know the angle, so I'm going to set up tangent of the angle. Tangent of 54. If I look at the chart above me, tangent is the opposite, which is t, over the adjacent, which is 18. All right? Tangent of theta, theta is 54, equals opposite, which is t, over the adjacent, which is my 18. So let's multiply it by the 18, and I'll have 18 times the tangent of 54 degrees is t, and I'll just use my calculator. I'll go 18 times the tangent of 54, and I get an answer of about 24.77 feet, or if you want to round it to 24.8, that's okay with me. So far, so good. Now, tomorrow, this one, don't make this mistake. This says feet, and this says inches. We've got to be really careful about this problem, okay? 4 feet is 48 inches. Okay, I'm going to put that right there and circle, okay? So let's put everything in terms of inches, okay? So I'm going to draw my ramp, okay? Wheelchair ramp. Here's my wheelchair ramp. Okay, it looks like that. My ramp is this side, It is not. This is like in the ground. You never even see that. It's in the ground. But my ramp is 48 inches because of the 4 feet, and the height of the ramp is 4. I need the angle of elevation of the ramp. It's that right there, okay? So I'm going to use my inverse button because I need an angle. Inverse button of opposite over hypotenuse. Opposite hypotenuse, I'm going to use sine, but I'm going to go sine inverse of my opposite over my hypotenuse. So I'm going to go sine inverse of my 4 divided by 48. And I get about 4.78 or about 4.8 degrees. So theta is about 4.8 degrees. And these wheelchair ramps really do have to have a small angle. 4.8 is small, but that's actually a pretty good angle for poor old Granny to get up. Okay? We're doing great. Number 11. An airplane flying at an elevation of 8,000 feet starts to descend toward the airport with an angle of depression of 8 degrees. How far is the plane from the airport? Okay, so let's draw a picture. Here's my airplane heading down to the airport. Here's my airport, my tower. It is at a height of 8,000 feet. If we need to know how far the airplane is from the airport, let's just call that x. Angle of depression is 8 degrees. That's right. There is 8. Now, what I know is that these two angles are equal. They're alternate interior angles. Okay? So that's 8. Then this angle is also 8. Alright, I want to find x, which is the hypotenuse. Opposite hypotenuse is sine. So I'm going to set up sine of theta, or sine of 8 degrees, equals my opposite, which is 8,000, divided by my hypotenuse, which is x. So if x is on the bottom, we'll multiply it up. So multiply up the x, and I'll have x is equal to x sine, getting ahead of myself, x sine of 8, bring that up, is equal to 8,000. And then I'll divide by sine of 8, divide by sine of 8. So I'll just use my calculator. What is 8,000 divided by sine of 8 degrees? It's a pretty big number, but it's a long ways away, and the answer is 57,482 feet, I guess. Okay, so far so good. Last one, we're almost done. Okay, number 12. Okay, we want to find the area. So the area formula we know is going to be 1/2 base times height. And we don't know either one. We don't know the base, and we don't know the height. But what I can do is first take and draw my triangle right in half. And I want to solve then for the orange triangle. First, let's divide this angle in half. So this is 68, and half is 34 degrees. Okay? If that's 34, then 90 minus 34 is 56. Okay? I just found them both. Makes it easier. Okay? So, here's what I have. Call this H for height. Okay? So to find the height of this triangle, I'm just going to use cosine. Adjacent and hypotenuse. So first, let's find H. So let's find H. Find the height. I'm going to do that first. So I'll set up cosine. Adjacent, hypotenuse. So I'll go, okay, cosine of theta, or of my angle, 34, is equal to my adjacent, which is H, over my hypotenuse, which is 10. Okay? Multiply up my 10 of 10 times the cosine of 34 equals H, which is the height of the triangle. Okay, so I'll just go 10 times the cosine of 34. And I get an answer of about 8.3. So the height of the triangle is 8.3. Okay, good. I've got the height of the triangle. Now the base, to get the base, let's just find this length right here. We'll call it x. That's from here to here. Okay, let's just find this length here, okay? When we get x, then we'll double it to get the entire thing. So to do that, let's use sine, opposite, and hypotenuse. So you do the sine of 34 is equal to my x over my 10. Opposite for hypotenuse. Multiply up to 10. I'll go 10 sine of 34 is equal to x. I'll just use my calculator. 10 sine 34. And I get about a 5.6. Okay, let's go back. This length is 5.6. So the entire base then is going to be a 11.2. Alright, we're ready to find the area. Okay, so the area of the triangle, one more time. Area is equal to, let's see, 1/2 the base. I know the base is 11.2 times the height, which is 8.3. Just going to use my calculator. 0.5 times 11.2 times 8.3. 46.48. And that's in terms of centimeters squared. Okay, I should be here third period, fourth, and after school if you need any help, and I'll be here tomorrow morning. So if you have any specific questions, you can ask. Please do the homework. There's problems on the homework that will also be on the test, so you need to do both to be fully ready for this test.